In this video, I'm going to go through a common process for evaluating anchors. As with many things in life, it's an acronym, SERENE. This is a process for evaluating the relative merits and drawbacks of an anchor, and it's important to remember that this is not about building the perfect anchor or assigning a pass-fail grade to an anchor. In particular, two aspects of SERENE are often in conflict with each other, and the characteristics you require of an anchor will differ from situation to situation. With that in mind, let's get started. S stands for strong. It comes first for obvious reasons. The job of an anchor is to support a load, so it's essential that our anchor be strong enough for its intended purpose. This doesn't mean that we should be building anchors that will hold a load up to 22 kilonewtons, as some training manuals would have you believe. Some situations might require our anchor to support a single person's mass. In others, it may require a fall arrest event for a single person. Still others might require a load significantly less or significantly more than one or even two people's mass. The fundamental question we need to ask ourselves here is my anchor strong enough to support the load I intend to place on it? R is for redundant. We want redundancy in our anchors because they support a live person and their failure could have catastrophic consequences. A redundant anchor is one where the failure of any single component in the anchor won't render the entire anchor inoperable. In previous videos, we've looked at several different approaches for building load-sharing anchors, and these all have redundancy built into them. Specifically, in an ideal situation, a redundant anchor will have at least two or more independent anchor points, with two or more independent connectors attached to them, possibly two or more independent lengths of rope, cord or webbing, down to a focal point. Here we have a very simple redundant anchor. This style of anchor is called a cordlet. The equipment that we use to tie it with is also called a cordlet, but it's simply a length of appropriate diameter cordage or rope tied into a loop. To tie a cordlet, I'll take my loop, clip it into my anchor points, and gather the strands of the rope together, pull them in the direction of anticipated loading, and then tie a knot. The knot that we tie doesn't really matter and depends entirely on the amount of rope we want to use to bring the focal point into position. Using more rope, tying a knot that uses more rope, we'll bring the focal point higher, closer to the anchor points. Using a knot, which requires less rope, we'll keep the focal point further away from the anchor points. Here I've used an overhand knot because the angle between our anchor points is already getting pretty large. It's very common to see cordlets tied with an overhand knot or a figure-of-8 knot. However here, because I have a very long cordlet, I've used a figure-10 knot, which is a figure-8 with an extra 2 half twists, just to use some extra rope. E stands for equalising. Will our anchor equalise the load we place on it equally amongst its anchor points? As we can see here, a cordlet does a pretty terrible job of equalising. It doesn't take much movement in the load at all before all of the load is placed on a single anchor point. Another type of anchor that's quite common recreationally is the sliding X. To create a sliding X, we start as we did with the cordlet, clipping our loop into both anchor points and gathering the strands of rope together. At this point, we can either place a half twist in one strand of cord, not both, but one, and place the carabiner through the two strands of cord, capturing the twist to create our focal point. Or, if we want redundancy in our connectors, we can take two carabiners and clip one through each strand. As you can see, this gives us perfect equalisation through any change in direction of loading. In the event of the failure of an anchor point, the anchor doesn't fail catastrophically, but it does extend substantially, dropping the load, potentially placing a dynamic force on the anchors, and scaring the pants off whoever's attached to the other end. This brings us to the final aspect of SERENE, NE for no extension. In the event of the failure of an anchor point, there should be no or minimal extension in the anchor. As we just saw, the sliding X performs terribly in this regard. Looking at our cordlet, if we were to simulate an anchor failure here, we see only a very minor extension in the anchor as the focal point moves to be directly below the remaining anchor point. This trait is very common amongst most anchor systems. We can either have excellent equalisation and significant extension in the event of a failure, or we can have very poor equalisation and very small amount of extension in the event of a failure. Part of our task in building an anchor is to make a compromise between those two extremes and determine where on this spectrum we need our anchor to be. Do we need absolutely no extension and are willing to sacrifice equalisation for that, or vice versa? In most situations, the appropriate place is somewhere in the middle. A personal favourite for me in recreational contexts is a variation on the sliding X that reduces the range of movement in the load through which equalisation can occur, and by doing so reduces the extension in the system in the event of a failure. To do this, we've simply taken a 3 metre length of cord and tied 2 overhand knots about 10 centimetres apart towards the centre. The load is then placed between these 2 overhand knots, set up in exactly the same way as we showed for a sliding X, either with a half twist and 1 carabiner or with 2 separate carabiners. In the event of a failure then, we get some extension as the load moves until it's stopped by these overhand knots, which act as limiting knots, but we get perfect equalisation through a fairly significant range of movement in the angles. In a rescue context, we most commonly choose minimal extension over perfect equalisation. Firstly, because the dynamic event associated with an extension of the focal point carries a greater risk when we have a casualty attached to the anchor, or potentially both a casualty and a rescuer. Secondly, in a rescue situation, we're typically more conservative in our selection of anchor points, and we'll usually have each of our anchor points be bomb-proof, or if that's not possible, turn them into bomb-proof anchor points by way of a back tie or a similar technique. And that's the Serene technique for evaluating anchors. I encourage you to apply this technique whenever you're building anchors, and as I said at the start of the video, this isn't about assigning a pass or fail grade to your anchors, it's about making considered choices and informed decisions when constructing an anchor.